Welcome to this video on CO₂ utilization and commercial viability. We will explore chemical synthesis, mineralization pathways, e-fuels, and strategies for scaling these technologies. In this first part, we examine the utilization paradigm for captured CO₂. CO₂ can be repurposed as a feedstock for high-value chemicals, including polymers like polyurethanes and commodity chemicals such as urea. Strategic pathways for utilizing CO₂ include thermocatalytic conversion, mineral carbonation, and electrocatalytic processes. The market outlook for utilized carbon is robust, with projections reaching $1 trillion in annual revenue by 2050, driven by sustainability mandates. Moving to Part 2, let's explore mineral carbonation technologies. CO₂-cured concrete systems utilize injection methods in curing chambers to enhance material strength while permanently sequestering carbon. This slide illustrates the mineralization mechanics, where CO₂ reacts with cement silicates to form calcium carbonate crystals, densifying the concrete matrix. Various alkaline feedstocks, from wollastonite to recycled aggregates, offer different reactive potentials and commercial readiness levels for mineralization. The market for CO₂ concrete mineralization is experiencing rapid growth, with a compound annual growth rate projected to exceed 17%. In the third part of our video, we discuss synthetic e-fuels. Catalytic processes, including the reverse water-gas shift and methanation, are essential for synthesizing syngas and green methane from CO₂. Aviation is a key sector for sustainable fuels, where synthetic e-kerosene acts as a drop-in replacement for conventional jet fuels. Optimized synthesis processes allow for a balanced yield split, targeting sustainable aviation fuel and e-diesel for broad industry application. Finally, the energy burden of water electrolysis remains a significant bottleneck, as cheap green electricity is critical for cost-effective e-fuel production. Moving to Part 4, we will examine the role of chemical catalysis in CO₂ conversion. Catalyst performance is often hindered by sintering, coke deposition, and trace poisoning from contaminants, emphasizing the need for high-quality feedstock. Photo and electrocatalytic paths allow for conversion at ambient temperatures, often using specialized materials to generate carbon monoxide or other valuable intermediates. Faradaic efficiency is a crucial metric, with 90% selectivity for complex structures like ethylene acting as a major target for modern catalyst development. In Part 5, we turn our focus to the techno-economics of these systems. Economic viability depends on balancing high capital costs for infrastructure with operational costs, which are highly sensitive to electricity pricing and feedstock availability. While some mineral products are already commercially competitive, sectors like synthetic aviation fuels require significant energy cost reductions to reach scale. Technology readiness analysis tracks the maturation of these processes, from lab-scale research to full industrial deployment. Our sixth section addresses the vital importance of life cycle assessments. We distinguish between cradle-to-grave, which accounts for the full product life cycle, and cradle-to-gate metrics, which focus on production stage impacts. Permanence varies significantly, from short-term storage in food and fuel to geological scale sequestration in mineral aggregates. In our final part, we look at how policy frameworks and carbon credits incentivize utilization technologies. Regulatory mechanisms like the EU Carbon Border Adjustment and UN Article 6 provide essential frameworks for valuing carbon reductions in global markets. We must carefully navigate systemic barriers, including additionality rules, risks of double counting, and lengthy certification processes for new infrastructure materials. Thank you for joining this module. We hope this overview of CO₂ utilization and its commercial future has been informative. If you are interested in consulting, research collaborations, or technical training related to CO₂ utilization, please reach out via the contact details provided on screen. Thank you for your interest.